We are starting a new unit on parallel lines, which is kind of a fun unit. I really like parallel lines. I think it's kind of neat. Creates lots of cool things. All right, so today we are talking about transversals, and we want to be able to identify and classify angles formed by transversals, so we'll talk more about that in just a minute. So to get started, we have some vocabulary and notation that we want to learn. So parallel lines, which I hope you know, are two coplanar lines that never intersect. Coplanar, remind me what coplanar is.
Two planes?
No, I think they're on the same plane.
Same plane, yeah. So you do have to exist on the same plane. So here I have the plane of my paper, and here's a parallel line, and here's another parallel line on my papers, okay? So they are on the same plane, so coplanar means on the same plane. And they are never going to intersect, never going to cross. And of course, on our ceiling, we have the lovely drop ceiling tiles here. So these lines that run from the windows to the doors are coplanar. They're on the same plane of the ceiling. And of course, these ones that run in the same direction are never going to intersect. Okay, so parallel lines, coplanar and never intersect. We use arrows. Arrows are used to indicate that the lines are parallel. I usually try to use colors. So these are the little markings for parallel on this picture here. These little, like, I'd call them more like triangles. Sometimes if I were writing them by hand, I would just use these little caret markings. But so this would be my marking for parallel. So either these little triangle arrows or these little arrows. So either one of these would be notation that we would use on our pictures for indicating parallel. Symbolically, using these two lines here, I could say that line AB, so we have our lovely little line symbol there, double arrow line. So line AB is parallel to line CD. So these two little slanty lines mean parallel. So anytime you see those two little lines together, that's parallel, which is pretty nice. So also parallel planes, and parallel planes are planes that never intersect. Do we have planes in this room that never intersect? That are parallel planes? Yeah, like what? The floor and the ceiling, yeah. The floor and the ceiling are two parallel planes that never intersect. And of course, we can go a little further than that. We've got the front wall and the back wall, right? Parallel planes that never intersect. So we live within parallel planes. Our rooms are all, we've got sets of parallel planes. So here we have a diagram, really, of two parallel planes. So this is plane J and plane K. And so we might say that plane J is parallel to plane K. And again, when we draw planes, we use sort of a parallelogram shape just to indicate that, but we want to understand also that when we draw a plane, we also understand it does go on forever. All right, so we're parallel, we know, are things that never intersect. So we want to talk about skew lines. Skew lines are non-coplanar lines that never intersect. So I think the easiest way to figure out skew lines is to say, hey, here's a picture of, this is a rectangular prism. I want to say, I'm looking at, let's say, line TW. So TW is this little edge here. I'm going to pretend that that little edge goes on forever. All right. I want to find a parallel line. So here we have line UV. So these are my two top little edges. Do you see that? Like, are my pens being clear? Okay. These are two parallel lines. They're coplanar because they're both laying on top of my prism there, okay? If I take one of them and just swivel it so that it's now it's no longer coplanar, okay? Now I swiveled it and my black line is now this like VR line. So VR and TW are two lines that would be skew. So again, I started with two lines that are parallel, and if I rotate one of them, I swivel one of them, first they started parallel, and then I swivel one of them, and now they're not coplanar. Are they going to intersect ever? No. And they're not in the same plane. All right, so if you start parallel and turn one of them, now they're skew. Okay? So here, for example, TW, I'm going to do segment TW and segment VR are skew. So give me another pair of skew lines. No. PQ and QR, do they intersect?
Yeah.
They intersect at Q. Those are not skew. They cannot intersect.
So like PQ and SW?
PQ is our front edge here, and SW is that far back corner going vertically. Yes, those are skew. So PQ and SW would be skew. All right, what's another pair of skew? So TP, that's the front edge here. I'm going to keep that line for now. So there's TP. Hi.
Can I borrow a protractor?
Yeah, in that cabinet, that first cabinet there. QU and TP are both on the front, and they both go the same direction. So QU and TP are parallel. So we need to rotate one of them. TP and SR, that would work, yeah. So TP and SR would be skew lines. So we've got one on the front corner and one on the back edge, again, and they're going in different directions. One's vertical, one's horizontal. They're never going to intersect. So TP and SR. Okay. So pretty interesting. So find two parallel ones and then twist one. Yes?
So this is a 3D shape, right?
It is a three-dimensional shape.
So how would SW and PQ intersect?
SW and PQ.
How would they intersect?
They don't. They aren't supposed to. They never intersect. Skew lines, we don't want them to touch. Yeah. Yeah, so skew lines should not touch. Yeah. Never intersect. Key word there, right? Non-coplanar and never intersect. Okay. That makes a difference. Okay, let's practice a little. All right, example 1. Name all segments parallel to AE. So AE, let's see, I guess I will just highlight that. There we go. There's our segment AE. I'm going to make it bigger with a red line there. Okay, so there's AE. What's parallel to AE? FB is parallel to AE. What else? HD. And? GC. Good. Absolutely. Those are all those sort of vertical corners, shall we say. GC. There we go. Segment GC. So all the little corners would all be parallel. Okay. Give 2 examples of parallel planes. How many letters do you need to indicate a plane? 3 letters. 3 points determine a plane, so we need 3 letters to name a plane. So give me parallel planes.
plane DCB.
DCB, so that'd be the bottom?
Yeah.
And
plane HGF.
Plane DBC and plane HGF. So the bottom and the top, absolutely. HGF. Oops, HGF. All right, so the bottom and the top. All right, what other planes do we have?
Plane GCD, so the back wall.
GCD, okay, the far back wall, okay.
And then FBA, so that front wall.
All right, plane, what did you say, FAB?
Yeah.
FBA?
Yeah.
Okay. Perfect. So yeah, the back wall and then the very front wall. So that's a good way to describe it. We got the top and the bottom, the front and the back. We could also do the left and right sides of our figure as well. Perfect. Name all segments skew to GH. So GH is right here. Highlight that sucker in green. So there's segment GH. FE would be parallel. So skew. So now take FE and now skew it. So FB. FB would be skew. So if you take a parallel and twist it, that's going to give you a skew line. So FB would be skew. What else is skew? EA is absolutely skew. Again, it started parallel and then we twist it. Now it's skew. What else? AD, absolutely, yeah. It's on a lower plane. So AD, you can imagine right here, AD is below that line. So yeah, AD, very good. And BC as well, yeah, you can imagine they are never going to intersect. One is up high, one is down low, and they're going in different directions, right? One's going left and right, one's going towards the back, all right? HE. No, again, H would intersect, so that is not skew. No intersecting allowed. Okay, cool. So here we have another little figure. Name all segments parallel to JK. So here I have JK right at the bottom there. What's parallel to JK? Yeah, OP. And that's really the only one parallel. That is an N right there. That got cut off by my whole bunch. But those are not parallel lines. So that's the only one. Name all segments parallel to NS. So here's NS. KP, that's one of them. That'd be parallel. KP. LQ would be parallel. Yep. LQ. MR. Yep. MR is parallel. And JO. Yeah. So all of those edges. JO. Awesome. All right. Name a plane parallel to plane JKL. JKL is the front face of this pentagonal base prism. What plane is parallel to that?
Plane OPQ.
Yeah, SRQ or OPQ. Yes, the back one. So plane. I'm going to go SRQ since I can see those letters clearly. All right. Okay, that's gonna look at that picture. It's looking pretty cool. All right, name 4 segments skew. Oh, I'm gonna use a different color. Let me use blue here. Skew to RQ. RQ is right here. So there's RQ. Skew to RQ. What? KR. Wait, did you say KR? KR does not have a segment connecting. That'd be a line through space that we haven't identified. Did I hear? Is there a done?
Or not KR, KP.
KP. Oh, KP, yes, that'll work. KP is definitely below, not going to intersect, going a different way. So yeah, KP would be skew, true. LK, yeah, LK, that's that front edge. Again, very far away from our RQ, not going to intersect. One's on the front, one's on the back side, so good. LK, J, what did you say, Quentin? J-O would absolutely work, yeah. J-O, and what else? Yeah, NS would also work as skew, sure. Lots of things that aren't going to intersect this guy way over here. Pretty cool. We got another one here. There's NJ. That wouldn't intersect. So lots of options, yeah? Do you see them? Yes. All right. Any questions on that? Good? Okay. So that was just some vocab. Now we want to talk a little bit more about transversals. Well, actually introduce transversals. This is the thing we're going to be working with most of this unit. So we want to really understand well what a transversal is. A transversal is a line that intersects two or more lines. So, for example, we have two lines here. Line T is crossing two lines L and M. So line T is a transversal. Line T is a transversal because it's intersecting lines L and line M. There's lots of like airplanes like Trans World Airlines, TWA, Trans World Airlines, TWA, that's an old airline. Trans means to go across, okay? And so that's what's happening here with line T. Gosh.
So could we say like transversal is almost like a angle bisector?
Well, it's not. So we don't want to use that word because angle bisector is super specific, but it does create lots of angles. And so what we have here is we have this transversal T. I'm going to highlight transversal T here in pink. When it crosses our two lines, we get a bunch of newly created angles. So we have there 4 dots right there, 4 angles there, and 4 angles here. Now in this picture, do they look like are they bisected, or is this maybe 100 degrees and this is like 80 degrees? Yeah? So they're not bisected, but they certainly do create lots and lots of angles, and that's what we're playing with in this unit. And so we have to give these angles special names because it turns out that they have tons of special properties. And so here we have a little picture. Again, here we have transversal T, and you can see I'm going to highlight him in pink because I think it helps to see that you're on different sides of that pink line, okay? So when we have this transversal T here, we create all these angles, and we went ahead and gave them numbers so that it's easier to identify them, okay? And so we have corresponding angles. Corresponding angles are angles on the same side of the transversal and in the same position. So corresponding angles have a corresponding position, all right? So when you look at this transversal and you say, hey, angle 1 is in a similar position. It's sort of, can you imagine that's sort of the upper left? Does that look like the upper left side to you? Okay, so where's another upper left side? Yeah, angle 5. So angle 1 and angle 5 would be called corresponding angles. Now, there's tons of them. So give me some more corresponding angles. 2 and 6, angle 2, and angle 6. Give me some more. 7 and 3, angle 7 and angle 3 are corresponding. And 8 and 4. So again, they're in corresponding positions. So you're thinking like upper left or lower right, okay? I maybe write that in upper left or lower right, that sort of thing. And that's what you're thinking. They're in a similar sort of position, a corresponding position. All right. Let's see. Alternate interior angles. Alternate. What does alternate mean?
Like
Other side. It's the alternate. It sort of switches, okay? Alternate interior angles are interior angles, interior. What are we between to be inside something?
The two lines.
Inside the two lines, absolutely. We crossed two lines. So everything in between those two lines is what we would call the interior, right? Does that make sense to you? Yeah? So in here is our interior, okay? And so alternate interior, what are we thinking? Alternate means alternating sides, okay?
Angle 4 and 5 would be alternate.
Well, 4 and 5 are on the same side.
1 and 8 and like 2 and 7.
So are those interior? Okay, give me interior angles that are alternating. 4 and 6, very good. 4 and 6. Angle 4 and angle 6 are on alternate sides of the transversal. One's on the left and one's on the right. And the interior, they're in between the two lines. Does that make sense to you? Okay. Then what's another alternate interior pair? Angle 3 and angle 5. Good. So alternate, those words have real meaning. Okay. Now, if in between the two lines is interior, what's the exterior? Yeah, exactly. The one, what did we say? The 1 and the 7. Angle 1 and angle 7 would be alternate. Alternate because they're on alternate sides of the pink transversal there. And they're on outside our two lines, okay? So alternate exterior, so 1 and 7, and then angle 2 and angle 8. So here we are, alternate exterior. So there's angle 2 and angle 8. They're on alternate sides, and they're outside the two lines we're intersecting. Okay. Consecutive. What does consecutive mean? In a row, one right after the other, okay. And I like how they've called them same side. That's going to come up. So consecutive means one after the other, but we can also use the word same side interior. What are same side interior angles, do you think?
4 and 5.
4 and 5. Angle 4 and angle 5. And again, they're same side. They're on the same side of the transversal and interior, in between. So what else? Angle 3 and angle 6. Very good. And then last but not least, so consecutive or same side exterior. Again, same side exterior is quite descriptive. They're on the same side, but they're exterior angles. So what are our same side exterior angles? 1 and 8. Angle 1 and angle 8, same side exterior. And then 2 and 7. Very good. Angle 2 and angle 7. All right, so same side interior, same side exterior, alternate interior, alternate exterior, and then corresponding. All right, all those words have real meaning, and I think they're pretty good. So let's check here, examples 3 and 4. Name the angle relationship. If no relationship exists, write none. So first of all, on example 3, what's our transversal?
Alternate.
R is the transversal there. That's good. I like to identify that transversal because I think it helps make it a little more clear. So what are angle 1 and angle 8?
Alternate exterior.
Good. Alternate exterior angles. We can do alt-ext. All right. And then let's see, angle 2 and angle 3. What are angle 2 and angle 3?
They're consecutive, same side interior.
Same side interior, yep. I'm going to do same side, SS interior. Same side interior. Good. 5 and 7?
Same side exterior.
Oh, one's interior, one's exterior. Corresponding. That is often the hardest one to recognize. Those are corresponding. They're both in that lower left position. And that's, sometimes hard. But you can see how 1 is interior, 7 is in between the two lines. That's an interior, and 1 is exterior. So that is not one of our other 4. So corresponding. What about 2 and 7? Alternate interior. 2 and 7, they're alternate interior, in between the two lines. 1 and 3?
Corresponding.
Corresponding. Very good. And then 5 and 8. So 5 and 8.
Won't they be
Same side exterior?
Same side exterior. Very good. Same side exterior. They're both on the same side, on the outside of our two lines. So same side exterior. Great. Ooh, and then it gets more complicated. Okay. All right. So now I have actually kind of a lot of transversals here. So this is going to be a little trickier. So we have to look a little careful. Let's see. So we have angle 5 and then angle 13. 5 and 13, what would you call those? Yeah. And again, if you have too much information, which is common in geometry, I have too much information here. Let's just cover up what we don't care about. And when you look, now I have transversal B, and those are definitely corresponding angles in the upper left position, okay? Upper left position. All right. All right, what about 7 and 14? Yeah, very good. Again, I can cover up the stuff that's not of interest to me. And now I see that they're alternating on alternate sides and in between. So alternate interior. All right, what about 3 and 6? Ooh, 3 and 6. Alternate exterior. Again, I'm only interested in 3 and 6, so I'm going to cover up all this information below so it doesn't confuse me. And now I see a transversal C, and so 3 and 6 are exterior and alternate. Alternate exterior. Good. All right, 9 and 14.
So here they're the same side?
Yeah, 9 and 14. Same side, same side exterior. Very good. And then 4 and 7. Same side interior. Very good. Excellent. How do you feel?
Okay.
Feel okay? All right, excellent. Really good. That is all I think I need to talk about today. And I think you